In this video, I'm going to give a short demonstration of NSoT, or Network Source of Truth. NSoT is an open source software from the folks at Dropbox that functions as an IPAM and state tracking backend. I find its API first implementation, robust community support, and flexibility very appealing. We will contemplate specifically the nature of configuration state in network implementations. In the demo section, I will highlight the IPAM and a feature I'm calling the iterable, for which I have a pull request with the project. Let's start off this presentation with a couple of questions. I'm going to keep these questions open-ended so that we have something to think about, and hopefully the demo will address, if not outright answer, how we want to approach some of these questions. So what is the source of truth for network devices? And by source of truth, I mean let's think of a scenario that will help address what exactly do I mean by this question, right? So today, as a network engineer, let's say you're adding a new VLAN to a switch. As an organization, you might have some standards. You might have some predefined VLANs, say web tier is VLAN 10 to 99, app tier is 100 to 199, database is 500 to 600, some standard within which your organization operates. Then how are we tracking this information, right? So basically we have defined these standards, and how we're tracking what is actually allocated. That is, either you're doing it through a spreadsheet or emails, or there's some potentially static method of a distributed source of truth. You might have a version of the file. There might be a central repository with a version of the file which may not be updated. Your coworker might have another version of the file, and your versions may not be in sync. Now, let's assume you have this. How confidently can you write a change control to add the VLAN without logging into the device and confirming that the VLAN isn't already on the device? Right, and I'm not just a food for thought here. Not expecting an answer. What about those of us who have some sort of version control? So I've been used to HPNA, where we used to do nightly backups of all devices across the network. So we would have nightly backup of the configurations. There might be others who are using GitHub or any other version control system. So how reliable is that state? Can you so again, going back to that scenario, can you on any given day go to that version control system and take a look at that configuration and then write a change control to add the VLAN without actually logging into that device? All right, so those were the two questions I wanted us to think about. Now, I'm going to make some assumptions here. So the audience is obviously network engineers who have been down the path of automation a little bit. So I'm going to make an assumption that you're familiar with Ansible, or you have any other equivalent tool, whether it is Cisco's NSO or SaltStack, or however you're implementing your automation for the network today, right? So just for ease of conversation, I'm going to call it a playbook, with which I'm most familiar with from the Ansible side. So let's say you have a playbook. Now you have a playbook to add this VLAN. Now, how are you going to actually provide the VLAN information to the playbook? The playbook essentially goes and does the device configuration. So let's say you have 5 switches on which this VLAN has to be added, and you're patting yourself on the back that you have an automation script that looks up the inventory of the devices, which are your 5 switches, and it goes and deploys this VLAN across the devices. Awesome. I mean, that is really good automation. But how are you supplying what VLAN should be applied to the devices? Most of us are still supplying this manually, either as a parameter to the script or as a separate YAML file with a bunch of variable data defined in it, or some other format of inputting data in a static format, right? So you either collect it, if you're using Ansible Tower, maybe you're collecting it from the end user as inputs, but still it's a manual way of providing the variable data. So that's the piece that I was trying to address through the feature I'm adding called iterables. Now, if you look at this drawing, I'm defining iterables as simply positive integers that needs to be incremented and have some sort of a unique identifier that is able to tie a set of integers together to a particular playbook, for instance. So think of a playbook as a service, right? So let's say you have a service to do X, and that service X is repeatable. So think of it in terms of let's say you want to create IPsec tunnels for your vendors. Now that's a repeatable service. So you take in certain input and then you churn out the config and you apply the config. So that's a service and that's repeatable. Now you have another service that is, say, creating VLANs in the data center. That's again potentially probably very repeatable depending on some standard, and so on and so forth. So the idea is each time you invoke that playbook or service, the iterable feature will provide you with the next available, whether it's crypto map number, VLAN number, port channel number, subinterface number, AS number, whatever that number is, it's going to provide you with that number, or it's going to provide you with more than one number, right? So one, for example, if you look at the crypto map service, maybe it requires a crypto map sequence number and a port channel number and a tenant verb, right? So all these different entities need to be tied together with a unique identifier so that you now have something closer to a CRUD system, right? So basically you are able to create, read, update, and delete the values that have been assigned through this backend. So now when you think about it, let's say you've created service X 5 times and you want to delete or remove the config that was done on the second time, right? So you have a service number, a service key associated with that. Now you have so that service key will help you identify the values that were assigned when that service was instantiated the second time. So using that, you should be able to go and delete those values that were previously assigned and make them available back in the pool. So what's happening is, I mean, when you think about back to the questions, now you have a backend, a source of truth that knows what is the next available value and is keeping track of your standards, it's keeping track of your limits, and it's keeping track of how you want to increment things. That was a very high level overview. So because I wanted to get into the demo and I didn't want this to be too much about talking about how we do state. So from a demo standpoint, I'm going to take a scenario that we are going to deliver IPsec connectivity as a service. And just for the sake of this demonstration again, I'm going to say we want to track VLAN numbers, crypto map numbers, and an encryption domain for each time a new IPsec tunnel is created, right? So these are the 3 iterables in this case that we're going to keep track of: the VLAN numbers, the crypto map numbers, and the encryption domain. Encryption domain is going to explore the IPAM feature of the product, and VLAN and crypto map numbers are going to explore the iterable feature of NSoT. For the demo, I'll be using an Ansible playbook called NSoT tester. Let's assume that this playbook is written to address the IPsec scenario. The scenario required us to keep track of the VLAN number, the crypto map number, and the encryption domain. Let us also assume that this is a repeated and automated service that your organization provides, implying that at a minimum, you will need to add configurations for creation of new tunnels and delete configurations when tunnels get decommissioned. In the first step, the playbook will set up the backend with some basic information. So it'll create a site, the supernet out of which we will derive the encryption subnets. It'll also set up counters that will keep track of the crypto map number and the VLAN number. Then I will demo the repeatable service. So here we will run the playbook a number of times to demonstrate the creation of multiple IPsec connections. Keep in mind that the intent of this demo is for the NSoT backend pieces and not necessarily the device configurations. Finally, from a CRUD aspect, we'll perform a delete operation for one of the tunnels that we will create to indicate how statefully we will remove the values that have been associated with the creation of a tunnel. So this is in lieu of if you are tracking this through a spreadsheet, and you'll have to remember to go and update that spreadsheet with the fact that some tunnel has been decommissioned or a CMDB or whatever that backend may be. For the actual demo itself, I have the NSoT server running on my host laptop, and it's going to spit out the debug messages out here, so we can take a look at all the requests coming in. And the control machine is going to be a Vagrant VM on the same laptop, which is simply an Ubuntu box and going to act as an Ansible playbook runner. So in a real scenario, this top panel could be a database sitting somewhere inside your infrastructure, and the Vagrant box could be your laptop, or it could be the Ansible tower or any other automation system that you might have. So before I execute any of the playbooks, let's look at how the backend looks like. So right now, I'm just refreshing the page. You can see that the site list is empty, so there are no sites that have been configured. There are no networks that have been configured. There are no iterables either, and obviously there's no iterable values or values assigned to the iterables. So everything is in a blank state. So the first thing I'm going to do is I'm going to run the setup playbook. And this is going to set up the basic site in NSoT. And you can see that the task names will give an indication of what exactly the playbook is doing to have an idea. And on the upper panel, you can see when a create task is being executed, there's usually a post or something like that associated with it. So basically these are API calls that the playbook is making to the backend and creating these different attributes and sites and things like of that nature. It just created the counters there, and the playbook is done running. So now if you go and look at NSoT, I'm going to do a refresh and you can see that there's a site that's been created, there is a network that's been created. So this is 10.119.0.0/24, and I'm designating it as a supernet out of which the encryption domain subnets will be derived. There are two counters that have been created. We have VLAN counter and a cryptomap counter. They have a min and max value and by how much they should be incremented as part of the service. So now, if this was any other scenario where you were tracking, let's say, different VLANs inside a data center for different reasons, if you have a standard that says web tier should be VLANs 100 to 200 in increments of 10, and database VLANs should be, 800 to 900 in increments of 1, you can create those as separate iterables and through your automation playbook call the next available data or next available value. So obviously we have not requested any values, so there's no values assigned to any of this stuff. Now the next step is the actual creation of the service. So from a demo standpoint, I'm going to call it. I'm going to call this customer 1, 2, 3, so on. So that particular tag, customer 1, is going to be our unique identifier, which is going to help tie together the VLAN number value, the cryptomap number value, and the encryption domain that's been reserved for this particular IPsec tunnel. So we'll go ahead and create that. So imagine, if you will, that this playbook is going and creating all the device configurations that are necessary on the routers in order to create that IPsec configuration. And in order to do that, the only input we are giving it is customer 1, right? So that's the unique identifier. The playbook knows where to go and how to get the next available number for the VLAN number, the cryptomap number, and the encryption domain. So the playbook is running. We'll wait for it to finish and then we can look at the updates in NSoT. You can see on the top here all the API calls that are going. You can see that the next value is being requested for the VLAN counter, the next value is being requested for the cryptomap counter, and the next subnet is being requested from the supernet, and the playbook is done. So let's go look at this. So there's not going to be any updates to the site. For the network, there's going to be a new network that's created at 10.119.0.0/28, and this subnet is derived from the /24. And the way we know that is, you can see that the parent ID for this subnet is 1, which corresponds to this ID here, whereas this one doesn't have. This is the parent network. There's no parent for this network. So this is the supernet, this is the subnet. That's how NSoT knows to give the next available /28 when we ask for it during the next run of the same service. Iterables, again, we have not created any new iterables, so there's no updates here. Now we have assigned values. So we have assigned the value 1 for the VLAN and value 1 for the cryptomap number. The thing I want to draw attention to is the service key, right? So there's a service key associated with each of these values. Both of these are identical, and you might have also noticed that that is the exact same service key that's also associated with the encryption domain that has been reserved. So what does that mean? So when we ran the playbook and it created our IPsec tunnel configuration and it reserved these 3 entities for creation of that service, it has tied these 3 entities together in one in sort of a in a row where you can identify these 3 values using this particular service key. So when we go to delete it or edit this information, if you have this service key, you are now able to identify which values need to be affected for a particular crypto map tunnel. And the way we are doing that mapping is by this unique identifier here, which I'm calling customer 1, customer 2, whatever, right? So I'm generating that service key based on this unique identifier here, which is easier to remember from an operation standpoint. You don't have to remember that service key or whatever. So that's the mapping that the playbook takes care of for me. So I'm going to run this repeatable play a few times. We'll create one more customer after this, basically to show that this is a repeatable service, and each run of this play has created a new IPsec tunnel configuration and reserved some backend values for us. You can see that the next prefix is being requested here. I'm going to run it one more time so that we just have a good enough sample size. So at this point, using our automation service, we have 3 IPsec tunnels that have been created. All right, while this is running, let's go take a look at the data in NSoT. F5. So you see when we ran the playbook for customer 2, this was a subnet that was reserved. It's got a new service key which is distinct from the previous one, but it's also going to be shared across the value. So this one here is going to correspond to this one here. And last of all, so I think the third customer has also been created by this time. Let's go and refresh the networks. Yeah, so /32 has been assigned for, the .32 has been assigned for customer 3. Now, for the final part of the demo, I'm going to show if we wanted to, let's say, delete the configurations that we made for customer 2. This could be a standard change control rollback, or this might be later down the line. Your company no longer wants to have this IPsec tunnel up and therefore wants to remove all the configuration for that. And also, when you remove the configuration, you want to reflect that the values that had been reserved for this particular service are now available back in the pool. So for the demo, I'm just using the same playbook. I'm just using different tags to do the delete operation. So customer 2 at this point was this guy. So ID 3, from a network standpoint, the .16 should disappear, and from a iterable standpoint, it's this particular service key. So IDs 3 and 4 should disappear. Let's see if that works. Still in the process of deleting. All right, the playbook has stopped executing. So let's take a look here. I'll refresh the page and it's gone. So you can see that the network that had been reserved for customer 2 has been removed along with the device configuration. Same thing, the VLAN numbers that were reserved has now gone back into the pool. So that's pretty much it from a demo standpoint. So to circle back on what what this video was all about was to show how we can have a stateful API based backend for network configuration automation using very robust open source tools that are available today. Thank you. I hope this helped.